This video is on neutralization reactions for acid-base chemistry. And basically what a neutralization reaction is when you mix an acid with a base, okay? It becomes neutral. They are opposites, so they essentially cancel each other out, okay? So we have that H represents our acid, and then we have OH representing our base. And all neutralization reactions are neutral because they make water. They also make a salt as well. The salt isn't pictured here, but that would be the other elements like in the equation. Okay, so when you mix an acid and base, it actually just makes water. It doesn't become more dangerous, they just cancel each other out. A titration is a physical performing of this neutralization, so it's like what you actually do. The setup kind of looks like this. You have a long skinny burette and then a flask at the bottom. And basically all you're going to do is you're going to add an acid to a base, and you're going to keep adding those together until it becomes neutralized, until it becomes water. And the whole reason why you're doing a titration is that's how you figure out what an unknown is. So if I just gave you some kind of random acid and we did not know what it was, you could perform a titration, and that would let you know how strong it is. You know it's been done when it changes color. So normally it'll turn like pink. That's how you know. So for the math of this, we're going to use M1V1 is equal to M2V2. M is the molarity, which is basically just the concentration of an acid or base. So it really tells you how strong of an acid or a base you have. It's also known as the concentration. And then V stands for volume. All right, so we're going to look at just two quick examples here. So when you're going, you should label the M's and the V's in the equation. So it says we have a 25 milliliter solution, milliliters, that is a volume. And it says it's completely neutralized by 18 milliliters of 1 molar NaOH. If you have two numbers that are next to each other, they will go together, okay? And it wants to know what is the concentration of that H2SO4. So it's asking for M1, and then these other numbers are M2 and V2. Basically, it doesn't matter which one's M1 or V1, as long as the numbers that are together stay together, okay? And now I'm just plugging in these numbers. And this is just like our physics stuff. This is just solving for M. So the molarity here is equal to 18 divided by 25, which is 0.72, and that's going to be an M for molar. All right, second example. What's the molarity? So it wants to know what is M for H3PO4 if 15 milliliters, that's a volume, is completely neutralized by 38.5 milliliters and 0.15 molar. Again, any numbers that are together are just going to go together. That's the only part you really got to worry about. So I'm just going to plug in these numbers. Plug in V's and M's. Now we're going to solve this. So I'm going to multiply that 0.15 times 38.5. Now I'll give us 5.775 is equal to M times 15. And then we're going to divide both sides by 15. And our molarity is going to be equal to 0.385. So basically, keep the two numbers together that are together, and just plug in some numbers, and that'll help you solve for your unknown concentration.